Now, on to our last session for the Australia region. We are all aware of the potentially devastating impact climate change poses for all of the humanity. And now, with AI, we have an opportunity to deepen our understanding of climate change and develop technologies to fight this battle. From modeling climate systems decades out to creating systems that provide advanced warnings of natural disasters, for addressing impact on agriculture and nutrition of humanity, and building out energy efficient society. Dr. Sunit Tyagi is a serial entrepreneur innovating across a wide range of technologies, leading businesses in areas of renewable energy, climate change, VLSI, and computing. Please welcome Dr. Sunit Tyagi, Managing Director, Insolaire Energy Private Limited, Director and CTO, iGreen Energy Corp, to give us a talk on how power of AI is helping us fight climate change. Welcome, Sunit.
Thank you very much for the warm welcome. Thank you for inviting me to this wonderful conference. I know it's virtual, but that's how it is global. Truly appreciate being part of this global initiative for getting all.ai off the ground. My topic is going to be AI for climate change. And I'm just doing preaching to the choir by listing here artificial intelligence being a family of technologies where a computer either mimics, complements, supplements, or even displaces intelligence from human being. I'm Sunit Tyagi, and I'll be talking today about climate change and how artificial intelligence can help us address some of the concerns with that. At a very broad level, AI has multiple benefits. The families of technologies for AI can help us improve features of variety of applications we are used to, give us better performance, improve the speed and efficiencies, reduce costs, and open up new social benefits. AI is all powerful. It's maybe considered as hype by some, but it is all a matter of how we utilize these new ideas and technology and algorithms which are being built by the stalwarts of AI. Machine learning, which is a subset of AI, really depends on learning dynamically from real-time data and improving the performance of predictions and control of real-life problem. Here, the real-life problem, we need to be aware of the context. What are we trying to do? Are we trying to run a machine? Are we trying to drive autonomous? Are we trying to grow better crops? Depends on sensing, collection of data, having it all collected, collated, corrected for any issues. Depends about the approaches. What are we trying to do with a physics problem, or how are we trying to utilize that information? So we take a real life problem. We use the data from that, apply learning algorithms to effectively train a model. And then using this model with inputs taken in real time, we use an inferencing application to make decisions and predict outcomes. The good news or the ability of machine learning is to then use those inferences application and dynamically retrain the model and improve the performance going forward. So machine learning is a very powerful methodology where pretty much without necessarily programming, we are able to solve very difficult problems based on the data collected. Now, looking at climate change, The prediction of what will happen from now till 2100 or 2100 years is in itself a very difficult task. Here I've borrowed a picture from Climate Action Tracker. They have taken on the task of predicting as to if all the nations pledge to certain policies, what would be the expected climate scene in this coming century? And depending on what are the kind of pledges, what are the kind of difficult options or optimistic or realistic scenarios. The shown here is the emissions, how they peak somewhere around 2030, 2040, depending on the commitments from the various nations, and how they come down. So these are the emissions are the cause of the climate change. That's well established science today. But what are the implications of this extra emissions? What do they lead to? Use of something like artificial intelligence can help hone in onto better predictions as we go forward. So that in itself is an application of AI for climate change, anticipating the actions being taken as a whole and that implication of those actions on what will happen to the world climate and what would be the results of that. Some of the impacts of climate change where AI can be used are listed here. We could predict, plan, and manage better with climate predictions, with local extreme events or floods and fires. And I will talk a little bit more about it later. As there's a push to reduce fossil fuels, a lot of electrification will require renewables. And renewables, unfortunately, such as solar and wind, are very intermittent and varying. That puts a lot of problems on control, balancing of the grids or electrification grid, which we have all around. And on top of it, as the fossil fuels are removed or drawn down and electric vehicles come into being, what happens is that the traffic of all the electric vehicles getting connected when everybody gets home from office at 7 p.m., 8 p.m., suddenly will put a large load on the grids. And such intermittent loading and such intermittent generations can cause a instability in the grid. How do we manage such a complex grid? Artificial intelligence has a lot of role to play in that. Smart grids, the smartness depends on AI, ML, and other approaches for that. So that's an area open for research, development of AI approaches to make renewables and smart grid possible. Another similar area is improving efficiency of energy use, efficiency of resource utilization, efficiency of sustainable materials, and efficiency of manufacturing like Industry 4.0. Smart buildings, smart cities, Industry 4.0 are all areas where AI is already making impact and is required to further develop. Mind you, this is all connected to climate change because improved efficiency would mean deferring some of the problems of climate change. Finally, AI also has huge implication in terms of control of the climate itself, controlling the impact of what extreme weather would have. So designing infrastructure aligned to the expected climate, modeling and even perhaps controlling climate. And I will talk again a little bit more about this part of. First, looking at the first scenario where we talked about predict, plan, and manage. What do I mean by that? Predicting using our artificial intelligence techniques, ability to anticipate with finer granularity and detailed weather is an example of prediction. Planning, How do we allocate scarce resources? What sequence of actions do we take? Planning also is an optimization problem, which can AI can add a lot of value to. Finally, managing. What should be the real-time actions? What should be the method to execute? All of these are part of management, and real-time dynamic AI inferencing recommendations are important aspects of it. Diving deeper into that, looking at the predictions, could we be doing country-specific climate change impact? Yes, we require that. What would happen in Germany? What would happen in India? What would happen in Australia has to be understood by those nations, and that's how they can predict the impact on their economies, on their populace, on their infrastructure, and be prepared for it. One of the major aspects is local extreme weather. We've had instances of what's called cloudbursts or atmospheric rivers dumping so much rain in a locality that leading to a lot of flooding. Can we predict such instances? Can we look at the weather as it is building up and anticipate from past episodes as to this could lead to a disaster and avoid such a disaster from happening? There's also the prediction of impact on the ecosystem. There are agriculture impact. Every degree Celsius rise in temperature has a 7 to 10% impact on the yield of crops. So does that mean knowing what was going to be happening in a particular country, can they anticipate the food requirements and change how agriculture takes place there? Similarly, planning now. How do we build a resilient infrastructure? Infrastructure which is not which is going to survive the onslaught of nature and help us live better. Sea walls, which would avoid flooding of low-lying coastal areas. Where do you build them? How do you minimize the cost of building such things? Roads and bridges, what should be their nature? Where would the flooding take place? And therefore, can we anticipate and plan to build it correctly and avoid disaster? Emergency response, which would be the areas where it would be safe for people to assemble? How do we plan how many resources are required in a particular corner of the country in case of an untoward incident? AI, with knowledge of past data, with episodes from learn from, can help us better prepare for such things. Similarly, urban planning. We've seen flooding of metropolis all around the world. We've seen flooding of rural areas or small cities. Can we design the urban infrastructure better to avoid such flooding happening? Similarly, we've had instances of forest fires affecting large populations. How can we better be prepared for such things? So that comes in the planning aspect also. Then moving on to the managing. Would a knowledge of a detailed local forecast allow us a day or two of warning sufficient to take the population out of danger? Can the emergency response plan be dynamically adjusted with real-time response tracking and awareness of the situation as it unfolds? AI would present multiple methods and algorithms which would allow us to do that in a real-time basis. So I've talked about prediction. Mind you, weather is typically predicted on 5 to 10 kilometer resolutions and using physics-based simulations, which take a lot of high-performance computing to predict. Using AI and knowledge of past evolution and patterns, it would be possible to do that on a much easier, much dynamic, much faster, and finer grained. Uh, and that is where AI would be very useful in making sure emergency responses, warnings, and forecasts are all done quickly and timely manner. Here's an example of the atmospheric river causing heavy rains. This just took place in November of 2021 in the northwest of America, Vancouver in Canada and Seattle in Washington state of United States. Just last week were suffering from heavy floods because of what's called the atmospheric river. And here is a atmospheric river scale picture showing the unfolding scenario. Could AI have anticipated such a development? Maybe not yet, but with sufficient number of such episodes, such data available, we can build models to say this thing is unfolding in a direction where it could lead to disaster in a particular domain, in a particular area. So AI has a very good use in trying to avoid disasters happening as have unfolded right now across the globe. India, Germany, China, every country has suffered from such heavy rains and flooding. Climate change is making it worse. So we need to build AI models for better forecasts with finer granularity. And by identifying ripe conditions, conditions which are leading to a potential disaster, we'll be able to better prepare for the impact and better manage. Similarly, for forest fires, here's an example of data taken from disaster philanthropy, where they're listing from how large the forest fires in California were. This part of the pie is all that was from 1932 to 1999. And this is for the last decade. And as you can see, nearly more than that has occurred in the last 2 years. So forest fires are increasing with drier, hotter summers. Climate change is making it worse. We need finer and better forecast. Applying AI for satellite images and looking for conditions, early identification of condition, and more importantly, early containment of incidents would help avoid the kind of disaster we have seen in the recent past. Moving on to a different aspect here. How can AI be used for engineering for extreme events? Here's an example of some work which we have done where we are looking at how to build wind turbines which can operate in areas prone to typhoons, hurricanes, cyclones, whatever you call them, but high winds. Typically, wind turbines cannot operate in high winds. More importantly, it could be dangerous if they don't survive. Using artificial intelligence approaches, we are engineering for working in the high wind conditions, using using sensors embedded in the turbines to react to unfolding real-time conditions, and effectively going into a stow position where the wind turbine is then safe, even in very high winds, such as to be seen in hurricanes. Why is this important? Because the strength of hurricanes are expected to increase with climate change, and the extent of where the wind turbines can be placed is strongly affected by their survivability. Using AI techniques, it can be possible to engineer for such extreme events, and that is what we are doing in this case. Another area is, can we engineer control of a local weather? We're researching how engineering a forcing, meaning of changing or modifying a local parameter to try to control the weather at the local location, using a cycle of engineered forcing, logging the data which resulted from the forcing, synthesizing, putting it into a model, and then putting it into a controller algorithm, and completing the cycle with a modification of the forcing. We believe use of artificial intelligence in such a cycle would allow us to control the complex dynamics which are seen in a prediction of a local weather or control of a local weather. With artificial intelligence algorithms, the old control methodologies, which were based on a predictive, descriptive model, are being displaced with somewhat of a black box models using the AI methodologies, where real-time data logging is fed back and fed forward in order to create a better, stable performance. So what happens when we say controlling? Here is an example of another work which we're trying to do, where we are trying to control the temperature across a coral reef. Coral reefs, when subjected to very high temperature, lead to bleaching, where the uh, the symbiotic which relationship between the polyp and the algae is broken under high temperatures. As a result, the corals bleach and die off. Here is an approach where using artificial intelligence, we are engineering for how to control the local humidity, how to force a local convection to create clouds on a reef and thereby blocking the heat from the sun and keeping the temperatures under control. All of this using renewable energy sources, and this whole loop of engineering is requiring complex dynamic response, such as possible using artificial intelligence. Coordinating actions of such machineries across large areas is another area where artificial intelligence would be very critical. So if one such machinery was creating cloud in a particular location of the reef, placing multiple such machineries, coordinating the actions across those machines requires synchronization. It's like playing like a symphony being conducted by a conductor. And that is where application of AI techniques is critical again. These are some examples of where AI is going to be very useful for climate change. And I repeat earlier foil, where we talk about predict and plan and manage for climate predictions, floods and fires, use for smart grid and renewables, improve efficiency, and finally, innovate to improve the future, where we can use artificial intelligence in a model for control the climate, the weather, and innovate to improve our future. Thank you so much for your time.
A big thanks to Dr. Tyagi for a wonderful address that covered range of things AI is doing to fight the enemy that is climate change.